Welcome. We want to look at a coin. Remember that a coin has two sides. One side is called a head, the other side is called a tail. And we all know probably that theoretically, if you take a coin and you toss it, you will either get a head or a tail. If the coin is a fair coin, in other words, if the coin is not biased, we expect that the head and the tail will have the same number of chances to actually show. We expect a 50% chance for a head and a 50% chance for a tail. But what happens exactly when we practically toss a coin? Does that always happen? Like if I toss a coin, say 100 times, am I likely to get 50 heads and 50 tails? The number of heads that I get after tossing a coin divided by the number of times that I tossed the coin is called the relative frequency. So I want us to carry out an experiment, toss a coin. We will start with 100 times, but I want us to toss it first of all maybe 10 times, then record what we get, then toss it again, say another 10 times until we get 100. Then check what exactly we get. Let me remove these numbers. Right, so let's start with tossing a coin 10 times. Now, we don't have a coin here. We're going to use a simulation. So we are going to be using GeoGebra. So I'm going to click on that link and open the GeoGebra coin flip simulation. And I want to choose one coin because I want us to toss only one coin. Let's take 0 here to represent the heads, and let's take 1 there to represent the tails. So I will toss the coin, like let's toss it. I know I can do it one at a time, but let's do 10 times. Let's toss the coin 10 times. This is what we get. It looks like we're getting 5 heads and 5 tails. You may want to ask yourself what that means. Let's record that. So obviously if I toss it 10 times and I get 5 heads and 5 tails, then that will be the probability, the relative frequency for the heads is 5 out of 10, and the relative frequency for the tails is also 5 out of 10. That is why I'm getting 0.5, 0.5. Right, we will continue that experiment. Let's see what happens. So I'll toss then 20 times and then 30 times and then 40 up to 100. Okay, so let's go back to the experiment now and see what happens. Let's throw it another 10 times. That makes it 20. And let's record that. We got 12 heads and 8 tails. So we're getting 12 heads and 8 tails. I put in the formula already to calculate for me the probability, or rather the relative frequency. This 0.6 that you see there is the 12 divided by 20. If you take 12 heads and divide by 20, you get 0.6. 8 divided by 20, you also get 0.4. I just want to change these decimals, just fix the number of decimals there. I'll make it not 2, but maybe 3, even 4. That's fine. Let's make it 4 decimals. Okay. So those are the answers that we're getting there so far. Let's go to the experiment again, another 10 times to make it 30. Now we have 16 heads and 14 tails. I hope you can see that. Let's record that 16, 14, 16 and 14, and observe the probabilities. The probability for the relative frequency For the head, this time is 0.53333, and the relative frequency for the tails is 0.4667, and so on. Okay, let's do that again 40 times now. Another 10 to make it 40, we get 2020. Wow, 2020. Let's record that. See whether you get a pattern. Obviously, if it's 2020, then the relative frequency for the tails will be the same as the relative frequency for the heads. Let's go again to 50 now. Another 10, we get 2327. I'll record that. 23, 27. And the corresponding probabilities are there. Let's go to 60. We get 2931. I'll record that. 2931. Then let's go to 70. We get 3139. 3139. Let's go to 80 now. 3743. 37 and 43. Let's go to 90. Then we will talk about this. We get 4149. 4149. Then let's go to 100. That's another 10. 4555. 4555. Okay. I just wanted to look at the numbers. Do you think they're very different? Do you see any pattern? I know that we started off with the same number of heads and tails, like when we did it, like the first 10 tosses gave us exactly 5 heads and 5 tails. Then later on, we got 20 heads and 20 tails, but the other numbers are all different. But are they very different? And what do you think you notice? Is there any pattern at all regarding these numbers, the relative frequencies of the numbers? In particular, I want you to ask yourself, do you think these numbers will kind of change and give you what you expect? Like, we know that we expect a theoretical probability of 50%. We expect theoretically the heads to be 50% and the tails to be 50%. So the theoretical probability, if you want, is 50%. So let's compare these probabilities that we are getting here to the 50%. Like the first one, let's leave that one. This one is giving us 0.6, and that is 0.5. But we are saying the theoretical probability should be 0.5. So our theoretical probability should be 0.5 for all of these, but these are the numbers that we are getting. We are not getting 0.5 all the time. There are some times where we get 0.5, but in most of these cases, we are not getting 0.5. Right, so look at the behavior of these numbers and check whether these will change with the number of flips increasing. For instance, that was 100 flips. You toss it 100 times, we're getting 0.45 for the heads and 0.55 for the tails, which is actually different from 0.5 for the theoretical probability. Now, I want us to go back there and let's carry out this experiment many, many more times. Like, let's just throw it many, many times because we can. Like right now, check what is happening there. Those bars keep on kind of overtaking each other. At some point, they are equal to each other. At another point, they're almost equal to each other. So I want to stop at this point. For instance, we have exactly 439 heads and 439 tails. That is just because I stopped here out of 878. Right. we are getting 439 heads and 439 tails. So you could ask yourself, do you think that 0.5 will be maintained? So we say after 878, we got 439 heads and 439 tails, which obviously gives us the relative frequencies of 0.5 for each of those. But the thing is, will that be maintained? So let's check. Let's continue a little bit more. Let's keep tossing that. You will notice that there are many instances, like if I were to stop here now, the answers wouldn't be 0.5, 0.5. But the question is, if I toss my coin many times, maybe a million times, we don't have time to do that a million times, but maybe a million times, what would you observe about the relative frequencies versus the theoretical probability? The theoretical probability is 0.5, but the relative frequencies are kind of different. I would like to stop here and record what I see now. I can see 2,110 tosses altogether, 1,097 heads, and then 1,013 tails. I just want to enter that for my record. So after 2,110, I got 1097 heads and 1013 tails. And look at the probability there. Obviously, we don't expect them to be equal, but are they very far from 0.5? Maybe you could argue and say they were never very far from 0.5 right from the beginning anyway. Right. But carry on with this experiment. I will just stop here now. I just want to stop after 3,000, and then I'll pose a question for you, and you can then take your time and try and answer that question. So let's wait for 3,000. Right, I will stop here. Let's take that. Okay, so that is 3,121. We're getting 1576 heads, and we're getting 1545 tails. I'll just record that as well for my records. So that is after 3121 tosses, we're getting 1576 heads and 1545 tails. And look at the probabilities. It really would be nice to get some time, find time to continue this experiment up to very, very large numbers, like tens of thousands if you want. Okay, so having done that, I would like you now to kind of answer this question for me. Take time and think about this question. What do you notice about the relative frequency and the theoretical probability of obtaining heads and tails as you keep on increasing the number of tosses? What do you notice between the theoretical probability, which is 0.5, and the relative frequency? Please do answer that question.